Welcome to the snow day review for operations management. This is review problem number 3. So as you can see by the process flow diagram on the board, this problem is about parallel processes. And what this means is that task A and task B are done by the same worker. This is represented with the dashed line around the two tasks. And I wrote here that worker 1 did those two tasks. Make sure that you do this when you're drawing the process flow diagrams for your midterm, which would be indicating which worker does which tasks if there's not a one-to-one mapping. Down here, task C is done by worker 2. Task C doesn't require any inputs from A and B, and therefore these two sets of processes can be done in parallel. That is, a worker 2 can be working on task C at the same time that worker 1 is working on tasks A and B. Then these two outputs, the components 1 and component 2, have to come together, that's what this represents here, come together for worker 3 to complete task D. So the example that we made up was that task A was making a batter for a cupcake and task B was baking the cake. So there is a dependency because you can't bake the cake until you make the batter, as opposed to task C is making frosting, which can be done at the same time that worker 1 is making the cake and baking it. Once the frosting and the cake are made, they're combined together and the frosting goes on the cupcake in the last step of this process. So we're asking, as we always do, what is the bottleneck? So worker number 1 has a total amount of time of 11 minutes per unit. Worker 2 has 8 minutes per unit and worker 3 has 4 minutes per unit. So the bottleneck is, you guessed it, worker 1, so worker 1, and the cycle time for worker 1 is the 5 minutes for task A and the 6 minutes for task B, gives 11 minutes cycle time. In other words, if we had a box and we were standing at the end of the process waiting for a frosted cupcake to land into our box, every 11 minutes a cupcake would come off of the production line, a frosted cupcake. Okay, finally the last question is process capacity. Process capacity, as always, is driven by the bottleneck resource. So if we can make 1 unit, in our case 1 cupcake, every 11 minutes, that is the process capacity. The question asked us to convert this into units per hour. So we multiply by 60 minutes being 1 hour, and this turns out to be 5.45 units per hour is our process capacity. One other question we might want to ask of this process is, what is the minimum flow time? So what is the minimum time it would take if we started empty in the system at the beginning of the morning to make a cupcake? It would take 11 minutes to get through the first baking of the cake. While that 11 minutes was going on, worker number 2 would have already started and finished the frosting. And so the frosting would be waiting here for 3 minutes until this was ready. So the first time through is going to be 11 minutes because this is going to dominate, and we add on to the 11 minutes the 4 minutes to frost the cupcake. So the minimum flow time would be 15 minutes. Thank you very much. That was problem 3.